All right, let's look at the distance formula. All right, so again, we have 2 points. First point has the coordinates x1, y1, and the second point has the coordinates x2, y2. All right, then we're going to use the Pythagorean theorem to establish the distance formula. And as you remember, if you have a right triangle, then we have one side squared and another side squared is equal to the longest side squared. So that's the Pythagorean theorem. So we're going to use that to find the distance formula. All right, so we are looking at trying to find the distance between these 2 points. And what we can do is we can visualize the right triangle. So I'm going to just extend this horizontal line here and the vertical line here. And you can see that there's a right triangle right here. So this is the right triangle we're looking at. All right, then we can find the length of the side. So see if you let's see, the length here is going to be simply the difference between x1 and x2. So I'm going to just write x2 minus x1. All right, this side right here is the difference between y2 and y1. So this can be written as y2 minus y1. Right? And d is the length of the hypotenuse. All right, so following the Pythagorean theorem, a squared, so y squared. Actually, can I write the b squared first? It looks a little bit better. So I have x2 minus x1 squared. So this is basically the b squared plus a squared would be y2 minus y1 squared. Right? And this is equal to hypotenuse squared. So it's going to be d squared. Right? And since we are looking for just d, not d squared, and we just take the square root of both sides. So we take the square root. Actually, I'm going to just go ahead and take the square root. So if you take the square root of this, d is going to be square root of quantity x2 minus x1 squared plus y2 minus y1 squared. All right, so this is the distance formula. All right, so let's look at a quick example here. Let's say you have 2 points, 2 comma negative 3, and the second point is negative 5 comma 7. Let's find the distance between them. All right, so I'm going to again name these. So I'm going to call this guy x1 comma y1 and x2 comma y2, right? And if you decided to call the first one x2 comma y2 and the second one x1 comma y1, it will not make any difference. You're going to get exactly the same answer. All right, so but in this case, so we have the distance d is equal to square root of x2 is negative 5. So you have a negative 5 here. All right, so this is a minus. All right, so minus, and x1 is 2. So we put 2 there. Then we're gonna square those. Right? Then plus. We have y2, which is 7. All right, minus. All right, and so y1, so minus 3. So maybe I should put parentheses. Whoops. parentheses minus 3, then I'm gonna probably should use this. So instead of the parentheses, I'm gonna use a square bracket so that I don't get confused with these. Right, squared. All right, so we got that. So therefore, so this is going to be equal to square root of. All right, so this is going to be, let's see, negative 7 squared, so it's a 49. And plus. All right, so this is a 7 plus 3, so 10. 10 squared is 100. So this is going to be equal to square root of 149. All right, that's it. I hope that this was clear.